morning here at the BASTA conference. It's so nice to see a full room here. A lot of people who are interested in artificial intelligence. This is my second talk of the morning around OpenAI, programming with OpenAI. The first one was very much about prompting. Prompting will be important in this talk too, but we will mostly focus on how to develop intelligent apps using OpenAI embeddings or embedding vectors. Just to give me an idea, may I ask you to raise your hands if you have been in my previous talk just before in this room? Oh yes, a majority, definitely a majority. I like that. That means that it wasn't so bad. Okay, I like that, but still we have some people in the room, and those of you who weren't here, don't worry, I will not, it is not required to have been here in the last talk. I will spend, I don't know, 5 minutes or so recapping the most important concepts so that everybody can follow along. My name is Rainer Stropek. I have been a developer for 30 years now. Yeah, I'm pretty old. I do a lot of work in the Microsoft area. I use C# since the very first versions. I do a lot of work with TypeScript and connected technologies. I love Rust, I love Go, and in the last few months I've done a pretty decent amount of projects in the area of AI, particularly OpenAI in the Azure cloud. And this is what you are going to see. If you have your own application and you would like to add some intelligence to it, particularly when it comes to retrieving structured data from databases and embedding that data in chats, for instance, that is exactly what we are going to talk about. If you have questions after this talk, feel free to link yourself up with me through LinkedIn, for instance. You can send me a direct message if you want on LinkedIn. You also find my email contact there. So if you have any questions, if you can't find the slides that I'm showing you here, just check it on LinkedIn. I'm also active on other social media platforms. I'm pretty sure a simple search will find me. Good, let's get started. Let's jump right in. Let's jump right into the core question of this talk today. What are embedding vectors? You can work with ChatGPT without ever hearing the term embeddings or embedding vectors. You can program with the OpenAI API without ever hearing about embedding vectors. Embedding vectors is an advanced concept. A concept that typically works behind the scenes. It's not necessary to understand it to be successful with ChatGPT and OpenAI. However, once you discover the magic of embedding vectors, you can do even more interesting things, and that is exactly what we are going to talk about. Let me describe what an embedding vector is with an analogy. Let's think about the different personalities in this room. I could ask you a question. I could ask you a question on a scale between 0 and 10. How open are you to new experiences? That says something about your personality, right? Then we can draw an arrow with a length of 100. And depending on your question, we can mark the length of this arrow. Maybe you said 30, then we would end up with an arrow like that. And then I can ask 100 people in this room, and I will get a certain number of measurements. And that is already an embedding vector. It's a one-dimensional vector. And now I can group this whole room into those people who are rather open to new experiences, gather on the left. And then I can ask you to group everybody who is not so comfortable with new experiences, gather on the right. And we are doing clustering. Clustering based on an embedding vector. A very simple one, granted, but we can find clusters, we can find similarities, we can find differences. Now I can ask you a second question. What about your agreeableness? In German, Verträglichkeit. Now what we can do now is we can add a second dimension to our diagram. Now we have an x-axis and a y-axis. And suddenly we have a two-dimensional vector. A vector that has two numbers. The first one represents your openness to new experiences, and the second one represents your agreeableness. And we can go on. I can add additional properties here. And we get a third dimension, we get a fourth dimension, we get a fifth dimension. We can add a lot of different dimensionalities. And math is not afraid of multidimensional vectors. When I was in school, I was afraid of dimensional vectors. 3 dimensions, okay. 4 dimensions, oh my god. 100 dimensions, I have no idea what you're talking about. Well, in math, the number of dimensions of a vector is really just an abstract concept. It's nothing complicated. By now, I feel somewhat okay with more higher dimensional vectors, but at the end of the day, embedding vectors are just vectors similar to what I showed you just now. Once we have them, we can use them, as I said, for instance, for sorting. I can ask anybody of you to stand up, ask him or her for their embedding vector about the personality, and then I can play partnership agency. I can find somebody else who is very similar to this person by looking at different embedding vectors and finding the nearest embedding vectors, characterizing a person that from his or her personality is very similar to the one that I'm looking for. As I said, I can do clustering. I can find duplicates and things like that. I think by now you should have gotten the idea. There is a very nice paper which I always show my students when it comes to this. It's that paper. It's called The Illustrated Word to WEC. I really like this one. It's also available as a YouTube video, and I took inspiration for this introduction from exactly that paper. It's awesome. And here you see that there are large language models that do exactly what I just did with personalities, but based on text. They are capable of turning texts into multi-dimensional vectors. We could do something that is very, very simple. We could say we create, let's say, 15-dimensional vector out of words. And we could say we simply take the ASCII value of every single character and use it as the value for one dimension. So the first ASCII value would be the first dimension, the second ASCII value would be the second dimension. That would be a very stupid vector. Now that would but we could do the math. We could work with that. Large language models were trained in a much more sophisticated way. What they can do is they can somehow bake the meaning of a word or a text into such a vector. And in this paper, the author does a great job describing, for instance, vectors based on a certain large language model. That's not OpenAI yet. I will come to OpenAI in a second. By highlighting the different vectors here with different colors. And just by looking at these 3 lines here, you see that king and man and woman are somewhat similar. We will take a look at more elaborate examples with OpenAI in a second. If you are interested in details after this talk, I highly recommend to work through this paper, and you will get a deeper understanding how this works, and you can even play around with other large language models beside OpenAI to gain a deeper understanding and maybe decide which model to use. So that's a quick introduction into embedding vectors. Now, how can we work with embedding vectors and OpenAI? OpenAI offers many different so-called modals. And in this talk, I would like to use Azure, the Azure deployment. I've shown that in the previous talk, but this time I am going to show it in a little bit more details. What you see here is a deployment, now it's correct. What you see here is a deployment of Azure OpenAI. You can deploy this resource type in your favorite Azure subscription. You can also choose data centers in Europe. Multiple data centers in Europe offer OpenAI services. So if your company is based in Europe, and because, for instance, of GDPR requirements, you are forced to use European data centers, you can do that in Azure. If you deploy the stuff, and I scroll down a little bit, you can use things like keys and endpoints, which will give you an endpoint URL, and this endpoint URL contains the APIs against which you can code. So you do not code against the OpenAI APIs, but you code against APIs running in Azure. You get a key, as you can see it here, but you don't need to use a key. If you want to do it in a professional way, which I always recommend to my customers, then you are going to use RBAC, resource-based access control, service principles, managed identities, and so on. Azure has been built with enterprises in mind. Granted, OpenAI nowadays also offers special enterprise services, but these enterprise services are rather new. You can take a look at them and then decide whether you want to go with OpenAI or if you want to go with their partner Microsoft in Azure. It really depends. It's your choice. But my experience, although here for simplicity I'm going to use the API key, I highly recommend to use some kind of Azure Active Directory based authentication if you program against Azure. Now the next one, and it's a very important one, is the modal deployments. This is where we come to embeddings. Now, here we just have a button, Manage Deployments, and if you press this button, you come into the Azure OpenAI Studio. Here you see it. It's a dedicated website which offers similar functionality to ChatGPT. So what we can do here, we can click on Chat if we want, and we get a nice little user interface. Let me make it a little bit smaller so you get the idea. Here you define the system prompt. If you were in my previous talk, you know what a system prompt is. Here you can just do chatting, and here you can define the configuration. So it's similar to the user interface of ChatGPT. You can use it in your enterprise if you want, but don't expect the same level of functionality and polishness as with ChatGPT. The ChatGPT web API is much better than the Azure OpenAI Studio, at least at the moment. So yes, it's good, it's an 80% solution, but if you want to have the full stuff, you want to go to OpenAI. Nevertheless, it's useful in an enterprise context. However, this will not be our core area of work today. Our core area of work, at least at the beginning here, is the deployment section. Here in the deployment section, you can deploy the different models that Azure currently supports. For instance, you see the ChatGPT 3.5 models. They are fast, they are cheap, they are nice for applications where you have limited budget per request, where you need to have a small token price, and you have a lot of uses. However, if you can afford a little bit more money, I highly recommend to go for ChatGPT 4. It's much more intelligent. It has much less hallucinations. At the end of the day, that delivers you a better result, but you have to pay more, and it's slower. So you have the choice: fast and cheap, but not as intelligent, or a little bit slower, more expensive, just like with us developers, right? A little bit, it's a little bit human if you want. Now, I'm just kidding, I'm just kidding. Last but not least, and this is the important one for the beginning of my talk, is that one down here, Text Embedding ADA 002. That is the model that is currently recommended for calculating embeddings. Okay? We do not calculate embeddings based on ChatGPT 3.5 or ChatGPT 4. We calculate embeddings on the ADA version 2 model. It's very cheap. You can simply do a search with your favorite search engine for Azure pricing, look up the price per token of this model. It's very cheap. So it's absolutely no problem to take tens of thousands of texts and run the ADA model on top of it, calculate embeddings. It will cost you just a few cents, a few euros. It's not really expensive. The other ones are just here for for compatibility reasons. Just forget them. If you build something new, please don't use them. These three models are currently the relevant ones. Okay, very good. I already deployed the embeddings model here, as you can see it. I called it embeddings. Every deployment in Azure has a name. You can create multiple embeddings, multiple deployments with different names. Here I deployed the embeddings model. In my case, it's running in, I think, US, because when I created this deployment, can I remember it correctly? Let me see. I think it was, it's running in the US because when I created this deployment, there has not been a ChatGPT-4 deployment in Europe, but things have changed since then, so you can also use European data centers. Now remember the name here, embeddings. Let's go here. Nope, that's the wrong one. That's from the previous. I have to switch to my machine here. Go to requests. And this is exactly what I want to have. Let me zoom in a little bit so you can really see what I want you to see and do a word wrap here. Nice. Let's remove that text, and that's our request. I want to draw your attention on this request. This is a REST API request. Here you have the endpoint of my Azure deployment. You see it here. Here you have the name of the deployment. That's the embeddings, the Ada embeddings version 2 deployment. I want to call the API for calculating embeddings. This is just the path. It's defined by OpenAI. The API of OpenAI and Azure OpenAI are compatible. So you simply have to change this part of the URL to switch between OpenAI and Azure OpenAI. Everything to the right is compatible, the whole payload is compatible. There are tiny differences. For instance, the content filtering, which I talked about in my previous talk, is currently only available in Azure, but in general they are pretty much compatible. So in our case, we are calculating an embedding, and all we need to do here is specify the text for which we want to create an embedding. Let's see. Let's, for instance, start small and start slow and simply calculate the embedding of a word. Let's, for instance, take the word king. We have seen it before in the paper, and now let's calculate the embedding of the word king. I will run this one, I will scroll down, and may I introduce to you, this is an embedding vector. An OpenAI embedding vector has 1,536 dimensions. Oh, a little bit scary, right? A vector with 1,536 dimensions. Don't worry, it's just an array of floats. See it as an array of floats. Forget the word vectors, just call it embeddings, and it's just an array of floats. That is what it is. Yeah? You see there are multiple numbers, and I can scroll down forever. It's a lot of numbers, okay, and at the end I see I've used one token, of course, because king is a very small word. If I would take a paragraph from Wikipedia or from your internal corporate knowledge base, for instance, then of course I would use more tokens in this case. Now, I have already created the embedding for the word king, and we could, for instance, create an embedding for the word woman, just so you see the idea, and we get totally different numbers, of course. Yeah, nothing special here, we can expect that. What I did, I already created the embeddings for king, for man, for queen, and for frog, and for programming language, something like this. So partly similar words, partly very different words, and we will see what we can do with that. Okay? Good. Nice. Let's go back to the slides. So, we learned about how to generate embeddings. Now, how can we compare these embeddings? I told you that we want to find nearest neighbors. or we want to group them, to do a similarity analysis, to do a cluster analysis, or something like this. And for that, we have a mathematical concept which is called the cosine, like in cosine, German cosinus, the cosine similarity. The cosine similarity is defined like that. It looks complicated, but in fact it's not. Because what we do is we calculate the so-called dot product. We simply multiply two vectors. You have all learned how to multiply vectors in school. If not, look it up again. It's not too complicated. You simply do a bunch of multiplications. It's really not complicated. And you divide that by the length, by the magnitude of the two vectors multiplied to each other. The good news is that in the case of OpenAI, these things down there, they are gone. Because OpenAI creates an embedding vector with the magnitude of 1. Always, it's normalized to the length of 1. Every embedding vector that you create with OpenAI has a length of 1. And as we all know, 1 times 1 is 1. And something divided by 1 is something. So therefore, the cosine similarity with OpenAI is just a dot product of two vectors. And that is not complicated. You could implement the dot product on your own, but I highly recommend to not do that, because if you simply calculate it with plain C#, you are not using your existing hardware to its full extent, because there are capabilities in your computer, like for instance SIMD. Have you ever heard of SIMD? SIMD support, anybody? It's a special hardware support in your processor that can apply multiple operations on similar data at the same time, or you can use your GPU and things like that. So at the end of the day, use a library that is really using the CPU and the capabilities of your hardware to the maximum extent to do the dot product of two vectors. We will not go into the maths here, there is enough outside. So let's take a look and analyze that. What I did, and I want to do this demo because I have seen over and over in many trainings that I did with customers in the last months and in projects that I did with customers in the last month, that many of them don't know a certain feature of ChatGPT, which I find super helpful when doing development work. You see, ChatGPT has a special feature down here, which is called Advanced Data Analysis. Previously, it was called Code Interpreter. Many people thought that Code Interpreter interprets code. That's wrong. That's not an interpreter for code. The Code Interpreter, or it is now called Advanced Data Analysis, is a tool with which I can do data science without being a trained data scientist. What it does, you can upload some files, for instance vectors. Then you can ask ChatGPT to look at those files and do data analysis on top of it. And what advanced analysis does, it's writing Python code in order to analyze the data for you. Let me show you how this looks. Now, I will not bore you by doing all this on my own. I will simply show you what I did in preparation for this talk. First, I want to show you that if you dive into this topic, use ChatGPT on your own. You can easily, here, ask ChatGPT to describe concepts like cosine similarity to you. And ChatGPT Advanced Data Analysis is very much able to describe the formulas, to analyze why in this case you can just calculate the dot product, it will give you examples, and so on and so on. Then you can upload some data. In this case, I'm just uploading a comma-separated file where we have 1,536 float values in these files, but in your situation you could add your revenue trend or some sensor readings from your machines. This is a safe space where you can upload files, I think with the size of up to 100 megs. You can upload PNG files and do an optical character recognition with it. You can, on the other hand, generate files if you want. You can say, generate me a CSV file with 1,000,000 random float values, and it can generate a file for you. And the point is that it does it by generating Python code. First, it describes the steps which are necessary to calculate the cosine similarity, for instance, between king and queen. It describes it to you, and if you were in my last talk, you understand and you know that ChatGPT is really good in writing programs. It's not good in math, but it's really good in writing programs. So what it does at the end of the day, let me show it to you, it writes Python code on the fly to do data analysis on the data that you have uploaded. It even doesn't understand what you uploaded. I didn't tell it that this is exactly that in that file. What it does, it tries to interpret it with a certain library, with NumPy in this case, and it will find out that the first approach that it took wasn't a success. So guess what? It will simply change its approach. It will rewrite the Python code in order to take a look at the first few lines, and then it will use its text understanding capabilities to interpret the format of the file. And then it will adjust its strategy, writing a new Python code that can now handle the format of the file. You do not need to specify the format of the file. And in that case, it is successful. It could load the vector. Then it writes a little bit of Python code to normalize the vectors. However, it will find out that the magnitudes of the vectors are very close to 1. Still, it does a little bit of normalization on top of it. We would know as users, because we have read the documentation of OpenAI, that the magnitude is already normalized to 1, but still, hey, if it likes normalizing vectors, who am I to tell ChatGPT to not have fun normalizing vectors? So at the end of the day, it will do some normalizing, and then it will simply calculate the cosine similarity and give us the ready-made value. What did I have to do? Nothing. I simply dropped a bunch of floats into it and used data analysis to let it do the heavy lifting of writing the Python code to analyze the data and come up with the correct result. Isn't that awesome? Many people don't know this feature. I love it. I use it frequently because in a lot of projects that I do, I have to deal with data formats, with files, with data that I have to analyze, and I don't like to write code that I don't have to. What does that mean for you? You have to at least be able to read Python. If you're not a passionate Python programmer, I don't care, but you have to read Python in order to work with this feature successfully. So let's go back to my slides, because I don't want to bore you with all the different cosine similarities that I calculated. And here you see at the end of the day what it's all about. We have king and queen, and they have a similarity of 91.5, let's say, %. So cosine similarity is 0.9154. And then it's interesting. If we compare king with frog, obviously it's more different. If we combine king with programming language, it's even more different. But this one is an interesting one. If we take king and König, German word for king, we have a pretty high similarity value. So what this system, what these embeddings do at the end of the day, they capture the meaning of the text. They capture the core content in this text. And that is a very important property. You can store a knowledge base out of your precious company databases, which is written in German, and offer an expert system on top of it, which works in Japanese. And it's perfectly fine. You can take the question in Japanese, calculate the embedding, and compare this embedding with the embedding of the knowledge base article, and it will decently work. Of course, it works better if you use the same language, but it will still work. That's a very important property here. So you see, this is what these vectors are all about, and this is what we have to do. So let's summarize it. Large language models can convert text into vectors, and the similarity of the vectors reflect the similarity of the text. And we are not talking about the technical difference, like the Lehmanstein distance. We are talking about the meaning. So if we take, for instance, two sentences which are similar content-wise, then the vectors will end at roughly the same point. And if we take two other sentences which are similar to themselves but not to the other two, we have different vectors. And we can use that to find duplicates, for instance. I know teachers who now do duplication, plagiate. Is the word English plagiate? Plagiatsuche? Sorry, I'm not sure about the English word, but I think you plagiarism, right? Yeah, I think it is like that. So something like this is used in schools nowadays to find very, very similar code paragraphs, for instance, when teaching coding. Clustering, searching for relevant articles in a database. Imagine what you can do. You can take your company knowledge base, a knowledge base of guidances for how to operate a certain machine. You can split these knowledge base articles into paragraphs, or into pages, or into sections, however you do that. Then you calculate the embedding of every single text paragraph or page or whatever you do, and you store all the embeddings for every single knowledge base article in the database. And if somebody enters a question, we can simply use the embedding of the question and look up the nearest neighbors of all the different knowledge base articles in the database. That is what we call a vector search, and we will definitely talk in details about that in a few minutes. And of course you can combine that with other technologies, with other search technologies. If you know that you are looking at a drilling machine and you are looking for knowledge base articles about this drilling machine, you can use regular search queries like the serial number of the machine, or the type of the machine, or the fact that it's a drilling machine. You can use a where clause in a SQL statement and then combine it with vector search to look in a subset of the overall database. So this is not replacing traditional search and retrieval mechanisms, it's enhancing traditional search and retrieval mechanisms. Okay, next one. Now we know what embeddings are. Now let's talk about how we can use them, how we can benefit from them. The first thing that we have to understand is that ChatGPT, the user interface of ChatGPT, doesn't help us at all in this area. We cannot calculate an embedding vector, we cannot do anything with it. What we need to work with is the OpenAI API. And if you were in my last session, you already know quite a lot about exactly that topic. At the end of the day, rebuilding ChatGPT is a boring task. It's meaningless. You shouldn't do that. There is one exception. If you want to have a custom version of ChatGPT inside of your network with very particular management capabilities like access control and cost allocation based on cost centers or whatever, feel free, have fun. I already did it for some customers. It's a lot of fun, but it's just an exercise. What we essentially want is we want to have specific behavior of ChatGPT. That was my first talk just before. And we want to integrate application-specific data in our application. This is what we want to do, and that is exactly where we use embeddings. What we also can do is we can do smart automation processes, but that is not a topic for today. Now, those of you who were in my last talk have already seen this picture. Bear with me for 3 or 4 minutes and then we'll up for something new. This is particularly for those in the room who have not touched the OpenAI API yet. Every request that you send to OpenAI starts with the modal that you want to use. Don't get me wrong, I'm not talking about calculating the embeddings, I'm now talking about the regular ChatGPT API. So that would be ChatGPT 3.5 or ChatGPT 4. Then you send the entire message history to the server. And in the break, multiple people were coming up to me asking after the previous talk I gave, hey, Rainer, what does that mean? If I send the entire chat history all the times to ChatGPT, I have to pay for a lot of tokens. You're right. That is what you have to do. I'm very sorry. That's it. Live with it. What you can do is you can consciously throw away a certain part of the history, but then ChatGPT will simply have amnesia. It will forget about what happened a few minutes ago. You could build a smart program that summarizes an older part of the conversation, and you inject the summary of the old part of the chat history. You can do things like that, but at the end of the day, yes, you have to over and over transfer the entire history. Functions, not a topic for now. Options, not a topic for now. Send that to OpenAI and you will get back some choices, usage information, how many tokens did you use, and some content filtering data. So that is essentially how the API works. Here is a short summary. You see, in this case, again, I am using Azure OpenAI. In this case, I'm calling the completions API. You see it here. We specify the messages. We have different roles. One role is system, which is the system prompt. See my previous talks. This is the user role. This is what the user said. And then there is an assistant role. This is what ChatGPT said. Okay? We need that foundational logic and that foundational understanding so that you can follow the rest of the talk. If you already knew that, now it's time to come back, to wake up again, because now we are talking about the new stuff again. Good. Let's talk about the fundamental pattern, how we work with embeddings in a larger application context. And there is one very important concept here, which I highly recommend that you remember. The topic is called Retrieval Augmented Generation, or RAG pattern. You can use that as a search term for further research in Google. RAG pattern, Retrieval Augmented Generation. What does it mean? The end user, here on the left-hand side, talks to the application. The end user poses a question. The end user sends a query. The end user issues a command. Let's stick with the question. Okay, the end user sends a question to the application. This is our application. This is not ChatGPT, this is our application. Now the problem is that this question is now in plain text. Previously, what did we do? Our old applications looked like that. We had a form, and if the user had a question, we have a lot of different input fields. Let's call it a filter form, where the users have to enter a lot of different queries. You can filter by this and filter by that, and date between that, and measurement range between that and that. A huge filter form. This is how our applications have been looking so far, right? And with this kind of applications and the RAG pattern, our applications look like Google. One entry field. User, tell me what you want to know. So this is essentially a user interface revolution that's going on. We can now handle plain text. Questions in plain text. Now, in order to be able to do that, we need to understand the question. So what do we do with this question? We calculate the embedding vector of this question. We take the question and translate it into 1536 floating point values. And then we send this embedding vector plus optional filter criteria, we can do that, to the database. In the database, we use query mechanisms, traditional query mechanism. If we know, hey, the context is only drilling machines, there is no point in looking through the knowledge base for CNC machines. We can filter on traditional drilling machines. So traditional query, fine. You can apply full text search, traditional full text search if you have something like that. But the point is, we add vector search capabilities. So we ask the database to do a k-nearest neighbor search. So we ask the database to take all the different text paragraphs, calculate the embedding vectors for all the elements in the database, and then do a cosine similarity analysis and sort the result based on the cosine similarity which I described a few minutes ago. Obviously, it would not be a good idea to recalculate the embeddings at every single query time. You could do that. You could simply take 10,000 knowledge base articles and calculate 10,000 embeddings And if you have a lot of time, you create a for loop and do the cosine similarity analysis in your own C# code, and then use LINK in order to find the 10 best matches. That will be very slow, very expensive, and not very fulfilling. Databases are much better in doing that, because first, they can very efficiently store vectors. They have a concept which is called indexes. You know what indexes are, right? Databases nowadays, many databases, know how to store vectors and how to apply indexing. Databases are very, very fast in looking up the k-nearest neighbors. They have dedicated search strategies for that. Unfortunately, I don't have the time in this talk to go into details, but you should definitely look it up. And more databases get vector search capabilities built in. Nowadays in Azure, let's take Cosmos DB for instance. They have vector search built in. Take Azure Search, that is something that I'm going to use here. They have vector search built in. You can also use open source vector databases, like Quadrant for instance, a company from Berlin, open source. You can run it locally in a Docker container if you want. It's available. Or you can use their software as a service offering, which is capable of running in many different clouds. If you want something like that and you're not in Azure, use Quadrant in AWS, for instance. You can definitely do that. So there are a number of different databases which are capable of storing multidimensional vectors and looking for multidimensional vectors. Then you get a result. And the point is that we do not want to just give back the knowledge base articles that we retrieved. We are not just a knowledge base search algorithm, but what we do is we take the original question that you see here and put this question into the prompt, and we also take the result of the database query and put that also in the prompt. So we say, hey ChatGPT, I got the following questions. Based on a database query, I got the following knowledge base articles. They might be relevant for the question. Please formulate an answer. So we are dynamically building the prompt in our application. This is exactly what you want to happen during a talk. My escape key just broke. I cannot press escape anymore. So if you see me typing on the keyboard like that, it's because of my escape key. So now we have the prompt, and then we send this prompt to OpenAI, and OpenAI will then build the response. That's the idea. That's the retrieval augmented generation, and then we send back this response to the end user. Okay? Good. Nice. Let's try the escape key again. Yes, I have to press it hard, and then it works. Good. Let's take a look at an example. There is a very, very good example that I would like to showcase here. It's this one. Of course, I will give you my slides. Just take a look at my LinkedIn profile. I will post it right after this talk. You can get the link from there. There is a repository, a GitHub repository, which is public. It's not private anymore. It's called Cognitive Search Vector PR. I love it, and many of my customers love it. It's a really, really nice showcase where the Microsoft guys implemented this RAG pattern in different languages, including C# and including Python. So depending on what you want to write, definitely take a look at this example. The example that I'm going to show in the next 10 minutes is based on this example, but I tweaked it a little bit so that it fits my story. But at the end of the day, you see a lot of stuff that is going on in this GitHub repository. Now let me show you the most important things so you understand what's going on. First, this sample, or I am going to use 3 NuGet packages here. The first one is called Azure AI OpenAI. It contains a really nice C# API for calculating embeddings and communicating with the OpenAI API. The next one is Azure Identity, which you can use for authentication based on API keys, and you can also use it for authenticate using service principals and managed identity. And last but not least, this sample is using the Azure Cognitive Search service, which is a serverless service for full text search and vector search. It's really an awesome tool. I've used it before. It got capable of handling vectors, and I'm still using it in many projects when now adding OpenAI support. How do you calculate embeddings? It's really simple. You simply spin up an OpenAI client. You do that by authenticating with an API key or with a service principal, and then you have a simple, very simple call which is called get embeddings async. All you give it is the name of the deployment that you want to use, embeddings, and some options, and that's it. Here you have the text where you want to calculate the embedding from, King or programming language or Frog, you've seen it before, in this case the question of the user, and it will calculate the vector for us. And we simply get the vector. Very simple, it's a one-liner, not complicated at all. Now, how does the RAG pattern then look like? First, you generate the embeddings for the query. This is exactly the method that you've seen in the previous slide. So we simply say, hey OpenAI, the customizer question, calculate the embeddings of the question. Next, we spin up a vector search. In this vector search, we specify how many results we want to have. In this case, I'm telling Azure Cognitive Search, hey, find me the 3 nearest neighbors based on a vector search. Then I specify the vector. This is exactly the vector that I want to use. This is exactly that's the vector that we are just looking for, and some additional things like I can do additional selections, and at the end of the day, we are doing exactly that. We tell Cognitive Search, hey, search the documents based on our query embeddings. Here you see the query embeddings, we put them into the query embeddings here, and what we get back is a list of, in our case, knowledge-based articles about Azure. Let me show you that in practice. Let's move to my different machine here, and let's go here to my sample project. Now what I did for the preparation of this talk is I have here a lot of samples. Let's word grab. The first ones are just from the sample that Microsoft prepared. At the end of the day, it contains a lot of descriptions about Azure services. This is a sample dataset coming from Microsoft, so obviously they are describing Azure and not AWS because it's from them. But I did something. I invented a new service. The service is called Avian Data Transmission System, ADTS. Sounds fancy, right? And it works on top of the RFC 1149. Do you know it? RFC 1149? It's transferring data via pigeons. Yeah, you can look it up. It's really a thing. It's very old. And in our case, we employed pigeons, Tauben, to Azure. So what we do in this ADTS, we are analyzing in real time the wing flat pattern with the wing flat pattern recognition system in order to transfer data using the wing flapping of pigeons. That's it. And the beautiful thing is that I also added support for ADTS to systems like private endpoints. So you can do secure networking with pigeons in Azure now. Did you know that? Well, obviously, ChatGPT does not know about this Azure service because I now did an NDA violation. I will lose my MVP title because I told you about this new Azure service before it came out. No, I'm kidding. I just want to demonstrate how we can incorporate data which is secure. It has never appeared on the internet before, so ChatGPT was not trained on this data. But still, we want to find exactly that data. So, what can we do? We can simply load this data in a vector search. And here you see the search service. I will not show you how you can load data in this search service because it's really, really simple. I'm pressing the escape key again. Click here, that is the search, and I can go here to fields, and the important thing is that we have here two vector fields in our search database. This says, if you can't read it from the back, 1536 dimensions in the title vector and the content vector. I'm using the title of the knowledge base article and the content. And I calculated the embeddings and filled the whole database up front. I did that before my talk with my data, including ADTS, including the Aviation Data Transmission System. That's the idea. Now, this is private. This is not in the public internet. In my case, it is in the public internet, but you can imagine that this is running in your virtual private network in Azure. Nobody from the internet can touch it. This can run in your local area network using databases like Quadrant, for instance. Okay, that's fine. So, what does that help me? Well, let's run our application. Here we are. Nope. Exactly. Good. Let's say .NET Run. This example does now the following. First, it will ask me if I want to refill my whole search database. If I simply want to recalculate all the different embeddings. I will say no, just take a look at the example so you see that filling the database with relevant data is just a few lines of code. It's very simple. Now, next I want to do a single vector search, this one, and I have prepared some questions which I think make sense. For instance, here I have a question which says the following. I will read it to you if you can't read it from the back. I have some pigeons and read about RFC 1149. Is there a way to connect my animals to Azure? I bet that everybody in this room has woken up in the middle of the night and asked himself or herself exactly that question, right? Now you get an answer. Let's press OK. Let's press enter. And what happened now is that the question was translated into an embedding vector. Then we did exactly the code that I showed you before. So we went to Azure Search and asked Azure Search to do a vector query and find the 3 nearest neighbors inside of our own custom knowledge base. Now, what we got back is we got back 3 relevant articles. And I built a prompt. And this prompt says, you are an AI assistant that helps users answer questions about services in the Microsoft Azure Cloud Computing Platform. You will give them context and ask a question. You must answer the question based on the context given. If the question cannot be answered using the given context, say, I don't know. Question, blah, 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 pigeons and Azure, context, and this are the knowledge base articles from our database. So we are injecting the knowledge base articles which we found through the vector search into our prompt. Now let's copy this prompt, this one, and now you have to understand that in practice your application would now use in the background a ChatGPT API. But for the sake of simplicity in this demo, I will simply copy the entire prompt, as you've seen it before, into ChatGPT so you know what's going on. But in real life, this is not the task of ChatGPT. This is done behind the scenes without the user seeing it, using the API that I described before. Good, let's do it. Let's run it. And let's get the ultimate Azure question. Where is it? Yes, you can connect your pigeons to Azure using Aviation Data Transmission System, ADTS. Azure provides IoT harnesses for pigeons and support RFC 1149 and RFC 6240. Secure and monitor with Azure Monitor. Oh, we got a nice little emoji. You can see that here. You know why I got this emoji? I forgot something. If you were in my previous talk, you know what's coming now. You are a passionate death metal fan. Sorry, that was the previous example. Watch my previous video if you want to know why we are talking about death metal here. But I think you got the point. At least we had something to laugh about. We have a cloud and we have a pigeon, right? And of course I can now add follow-up questions. I can, for instance, say, can I connect my pigeons using Azure private endpoints? Let's see whether it works. Yes, you can connect your pigeons using Azure private link with Azure private endpoints, and again, emojis. And at the end, I want to say, what is the name of Bart Simpson's sister? We all know it, right? Come on. Trust me, I tried it before. It said I don't know. Whatever, I have to work on my prompting. That's real life. Yeah, I have to work on my prompting. Whatever. Maybe it was because of the system prompt. I don't know. Okay, if all demos work, but just this one, yeah, it's fine. It's fine. I think you got the point, right? And that's the point. That is exactly what I wanted to show you. Let's quickly summarize what we learned in the past hour. We learned what embeddings really are. Embeddings are vectors. Vectors with 1536 floating point values. We calculate these embeddings based on large language model, and I showed you how you can do that with the OpenAI API. I showed you how you can do that privately in Azure for an enterprise context where you might not be able to connect your systems to the public internet. Then I showed you how you can use the RAG pattern in order to fill a database that is capable of doing vector searches with embeddings about your custom knowledge base articles, for instance. And at the end of the day, I showed you how you can use prompt engineering to build a prompt and answer the questions of your customers intelligently. What you can also do, if you spend a little bit more time for your prompts, you can, for instance, add additional intelligence and add, for instance, sources to your answer. You can tell ChatGPT that it should not only give an answer, but it should also tell the user from where it generated this answer. And that is very important for enterprise contexts, because if somebody stands in front of a machine and says, dear application, this machine is currently about to explode. What should I do? You maybe want to add a reference that says, okay, there is a knowledge base article. If the machine is doing this and that, you should do that, but don't trust me fully. Read that article first to make sure that you don't make things worse. So giving sources is also possible in that RAG pattern, because at the end of the day, you have the query to the knowledge base, which is the basis of your vector search. That is what I wanted you to show. Thank you very much for coming. Thank you very much for your interest. It was my last session for this year's BASTA. Thank you for joining maybe multiple of my sessions. I really enjoyed it. I wish you a beautiful BASTA. If you have any questions to the topic for this talk or the previous talk, just come to me in the front and we'll have a chat. We can do some additional discussions here. Thank you. Enjoy the rest of the BASTA conference.